Welcome to Techlearners. In today's lesson, we will talk about simple data structure in Java. In Java, we have three main simple data structure. One is linked list, the other is stack, and the third one is queue. In today's lesson and in upcoming few lessons, we will be talking about linked list first. So let's see what we mean by linked list. Linked list is a linear collection of data elements, and these data elements are called nodes. These nodes point to the next node by the means of pointers or links, or we can also say with the help of the address of the next node. Each node is divided into two parts. The first part contains the information, or we say the data or the value, and the second part contains the address of the next node. We were talking about this link to the next node. So this second part contains the link, pointer or address of the next node. So a node in a linked list can be assumed in this way, which contains two parts. One is the information or data or value, and the other is the link, that is the address of the next node. For example, you can see this is a node. In the first part we have a value, that is 45, and in the second part it has a link which is currently null. Null means this node is not pointing to any other node because it's not connected right now as a linked list. Let's talk about what is the need of the linked list. The linked list overcome the drawback of arrays. Yes, what was the drawbacks of the array? That the number of the elements in an array needed to be predetermined, but here in the linked list we need not to be predetermine these number of elements. So we can add the elements later, we can delete the elements later, we can update the elements later. That was the drawback of the array, that we could not add the number of elements later, and we have to define the size of the array right? The second need of the linked list is that more memory can be allocated and released during the processing. That is why we said that we can add nodes later. That means we can add more memory, or we can allocate more memory. We can delete the nodes later. That means we can release the memory during the processing. The third advantage of the linked list is insertion and deletion is much easier and simpler as compared to array. So let's see what is the example of a linked list. So this will be looking like a linked list which is containing here three nodes. This is node number 1, node number 2 and node number 3. We have a start. This is called as a header. This header will point to the first node, that is called as the head node. So this is the head node of the linked list. This node having two parts. One is the data and other is the link. So this is the data value, and now this link is pointing towards the next node in the list. So what is the next node? This is the next node. So this link is pointing to the next node into the list. Again, next node have two values, one the data and other is the link, and now this link will point to the next node into the list. And what is the next node? So you can see that this is the next node into the list. So again, this is having two parts, one is the data value and other is link. Now we can see this is the last node into our linked list and to our example linked list, and this is null. Why null? Because this node is not pointing to any other node in the linked list, and this node is called as the tail node. So we say the first node in the linked list is called as a head node, and the last node in the linked list is called as the tail node. So let's consider the types of the linked list. So we have two types of linked list. One is the singly linked list and the other is the doubly linked list. So in today's lesson we will talk about singly linked list. Singly linked list, when the list has a header reference that points to first node, it is called as a start. As we have seen into the example that this is a start, this will point to the first node in the linked list. So we have a start pointer. The list has a sequence of nodes. The simply linked list has a sequence of nodes. So you can see this is a sequence of nodes. Node number 1 pointing to node number 2, node number 2 pointing to node number 3. And if we want to reach to this third node, then we have to go from start. This will indicate to this first node. Then we'll reach to the link of the first node. This will take us to the second node. And from the link of the second node, we will reach to the third node. So this is basically a sequence. So simply linked list has a sequence of nodes. Each node consists of two things, one a value and one a link. This link points to the next node. And yes, the last node contains a null link. That means the last node will not point to any other node, as obviously it is a last node. So for example, we have this start pointer pointing to the first node. This is called as the head node with value 10 and a link. Now this link will indicate to the next node with a value 25 and another link, and this link will indicate to the next node in the list with the value 43. And now in the address part or in the link part, we have no link because this is the last pointer. So we will mention null here in the address part, and this last node is known as the tail node. So let's see what operations we can perform onto the linked list. We can perform insertion. This insertion can be in two ways, whether the list is assorted or the list is unsorted. So we can perform insertion, we can perform deletion of a node, we can search the value in a node, we can traverse throughout the linked list, we can concatenate more than one list, we can split one list into two or more, and we can reverse the list. So this reversal can be performed with the help of creating a new reversal list, or we can reverse the nodes of the same list as well. So let's get more deeper into the simply linked list. We will also see the program in the same lesson today that is based on the singly linked list. So how we can create a singly linked list? Let's go and see these steps. The step number 1, create a class node. Create a class node which has two attributes, that is a data and next. This next is basically the pointer to the next node. Then in the next step, we'll create another class which has two attributes. And what are these two attributes? Head and tail. As we can see, in any linked list, we will have the head node as well as the tail node. Like in this example, the first node was the head node and the last node was a tail node. Imagine if we have only one node in a linked list, then what will happen? That single node will behave as head and as well as tail. If we have a single node, so this will be head as well as tail. So the next step is add nodes. So now we'll add a new node to the list. Just to add a new node to the list, we have to note something. We have to do something. What we will do, we'll create a new node just like this, new node with the value, and obviously in a new node the link will always be null. So we'll create a new node with value and null link. Then we'll check if our list, and we'll check in our list whether the head is equal to null. That means whether we have a head node or not. If we do not have a head node, that means the list is empty. If we do not have a head node, that means the list is empty. And if the list is empty, that means the node we are inserting will be our new head node, and even that will be also our new tail node. So if the list is empty, both head and tail will point to the newly added node. So this will behave as head as well as tail node, because this will be the only node into the list. Now if the list is not empty, that means we already have at least one node into the list. Then the new node will be added to the end of the list. So it will be added to the end of the list. Where it will be added? It will be added after this last node, and this link will be updated and will point to the new added node, right? So this new node will be added to the end of the list, such that the tails next will point to the newly added node, and after this the new node will become the new tail of the list. So this is how we can add a new node into a list. Next, we will display, and we can display all the nodes that are present into the list. And now we define a node current, which, just to display, we will define the node current which will initially point to the head of the list, and we can traverse throughout the list. We will see in the Java program. We are going to see the Java program, and then we can simply display each node with the help of the iteration. So this is how we can create a linked list, or we can have it. Let's understand this with the help of an example. Let's say if we want to create a new list. So the first step, we need to create a new node. So let's say this is our new node with some value, let's say 20 and null. In a new node, we always keep this address part as null. So we want to add this new node to the list. Let's say this is a list. Currently this is empty. That means we do not have any node into this. So we'll add this new node into our list, and this new node will become our head as well as tail. So this is the first node added to the list. Now again, if we will create another new node, let's say if we are creating this new node 40, so this will be added to list. Now we can see that this list already contains one node. So we need to add this node at the end of this list. So we'll add this node at the end of this list. That means after the tail. And now we'll point, let me place it on a proper place. Okay, right. So now we will change this null, and we'll add the link which will point to this new node. So this will point this new node, and now this will become our new node, will become the tail. So now this new node will become the tail node for us. As you can see, this is null, right? So this is how we can add a new node to the list. Let's say if you want to add one more node, so this is one more node we are trying to add into the list. So what we need to see, we need to go to the tail. We can see this is the tail, so we'll add this at the end of the list, and we'll create a link. We'll create a link, and this will be updated. This link will be updated. So now this is another node added to our list, and now we'll update this tail, and now this last node will become our tail. So this is how we can add nodes into our linked list. So now let's go to the Java program and see how this can be coded. So let's see how we can create the linked list. So I have created a simple class singly linked list with the name singly linked list. Inside that class, I have created a class node. So remember, this is the first step, that we need to create a class node with two data members, data and next. So this is the data value, the first part of a node, and this is the link part of the node. Now I have created this constructor node, which I'll pass data. That data will be assigned to the data part. So we'll be using this keyword to indicate the data members of the same class, of the current class, and we'll assign null to the address part or to the link part, as we know that every new node contains the data but contains the link as null. So this is how we can create a new node. So now let's go and create two nodes, head and tail. Currently both the head and tail will be null because initially the list is empty. Now we'll create add node function in which we'll pass the data value, and using the node class we'll create the object of that node class just by passing this data value. So we have just passed this data value and we have new node. Just remember this constructor. So we are calling this constructor, and with the help of this constructor we are creating a new node just by passing the data value. Now we need to check whether the list is empty or not, and how we used to check. we'll check if the head is null, then obviously the list is empty. And if the list is empty, we create new node as head as well as new node as tail. Otherwise, what we need to do is we need to add the new node to the last of the linked list. That means to the next of the tail. So we'll use tail.next and we'll assign the new node. That means we are adding new node after the tail node, and the new node will become our new tail. So if you remember, we just add a new node after this tail and we update this link to the new node, and then we'll create this new node as the tail node. So these are the steps we are creating here. We are adding the new node to the next of the tail, and then we are converting this new node as our tail node. So this is how we can add a new node to the linked list. Now, how we can display this list? For that, we need to use the current node. We are using a current node, and we are making the head node as our current node. So we are making head node as our current node. Again, we'll check if the head node is null. That means the list is empty. So we'll simply display the message list is empty. If it's not null, then we need to iterate through the list. So we'll iterate till current is not equal to null. So we have made this head as our current node, so we'll display this. Then we'll go to the next node, then again we'll display the value of second node. We'll go to the next node and we'll display the value of this node, and now you can see that the link of this tail node is null, so we will not iterate further. So in this way we will be able to identify the extent of the loop. So we'll run the loop till current is not equal to null, and we'll display the data current.data with the help of the data, and we'll change the current node by its next node. So the next node of the current now will be the current node. So this is how we jump from one node to the other node, then to the third node, and this will continue till we reach to the tail node. So this is how we can iterate through, or we can display the nodes or the values of the nodes into the linked list. Now the main function, inside the main function we need to create the object of our class singly linked list. So we have created the object of the class. I have used the scanner class to accept the input from the user to accept the data values of the node. I'll use a for loop, and I have created 4 nodes. I will create 4 nodes. So I'll accept the values of these 4 nodes, and I'll create new node by just passing this dt, the value accepted from the user. So slist.add node, and we'll pass the value. So this is how I can add node to my linked list. And then finally, once I have added all the nodes, I can simply call display method and can display my linked list. So let me compile this and execute this program for you, so that we'll be able to understand the execution of this program. So let's go and execute this singly linked list program. So okay, so here is it is asking, it will ask me to enter, please enter value of node 1. So let me enter, let's say 4. Now please enter value of the node 5, let's say 6, and please enter value of node 3, let's say 10, and node 4. I had run loop for 4 nodes. So now you can see it has accepted all the values of 4 nodes, and now the nodes of the singly linked list 4, 6, 8 and 10. So this is how we can work with the singly linked list. We can add nodes and we can display the nodes into the singly linked list. I hope you have understood the concept of the singly linked list. We will be coming with more lessons with more operations in singly linked list as well as into the doubly linked list. So that's it for the today's lecture. Thanks a lot. If you have not subscribed my channel till now, please subscribe the channel for more such videos. Hit the like button and share the videos in your community. Thank you so much.